I welcome you all to my second session on mole concept. In this session, you will learn a few applications of mole concept. You know what is meant by a solution. When a solute is dissolved in a solvent, you call it a solution. When the solvent is water, it's called aqueous solution. When the solution is prepared for some experiments involving calculations, you have to be very sure about the concentration of the solution. You should know the exact concentration of the solution. Concentration is also called strength. They mean the same thing. Concentration or strength mean the same thing. Now the concentration of a solution can be expressed in a few different ways. I'll list them now for you. First one is called mass percentage. Second one is called molarity of a solution. Third, molality of a solution. You can also express a concentration in what is called normality, mole fraction, and sixth one, parts per million. We will take up one after the other. Mass percentage is by far the simplest one. When I say a 5% solution of salt in water, it contains 5 grams of salt in 100 grams of solution. Note it carefully, it is 100 grams of solution. So how will you prepare that? You will weigh exactly 5 grams of the salt and 5 grams of salt and dissolve it in 95 grams of water, so that the solution has a mass of 100 grams. So it is always a mass of the solution for mass percentage. Now, if 5 grams of glucose is added to 20 grams of water, 5 grams of glucose in 20 grams of water. What is the mass percentage? See, 5 grams is dissolved in 20 grams of water. You have what should you consider? You should consider the total mass of solution. So the total mass of solution is 25 grams. So 25 grams of solution contain 5 grams of solute. 100 grams of solution will contain how much? That will be 20%. Is that clear to you? So this is how simple it is. We will consider the reverse of that now. How many grams of sodium carbonate must be added to prepare 50 grams of 2% solution? That's the first one. 2% solution means 2 grams of sodium carbonate must be present in 100 grams of solution. So for 50 grams, it should be 1 gram. Isn't it so? 100 grams of solution contain 2 grams. So for 50 grams, it is 1 gram. The second subdivision is in 1 kilogram of 2% solution. So in 1000 grams of 2% solution, it will be, for 100 grams it is 2 grams, for 1000 grams it will be 2 into 10. So that will be 20 grams. This is quite simple, so there is no difficulty in understanding all that. We will pass on to the next one called molarity. Molarity of a solution is defined as the number of moles of solute dissolved in 1 liter of solution. You have to note here moles of solute. Weight of solute is given here in moles, and there, see in the earlier one, mass percentage, we considered 100 grams of solution. Here it is 1 liter of solution. There it is mass and here it is volume, 1 liter of solution. We can write it like this: molarity, which is normally denoted by capital M, is given by number of moles of solute by volume of solution in liters. Volume of solution in liters. In liter. Okay, liter. Now, for number of moles of solute, we can write N, and we will write V in liters. And you know N is obtained by dividing mass by molar mass, isn't it? Molar mass by into V in liters. This is the simple formula you can use for calculating molarity. We will do some simple problems to understand it better. Let us try to find out the molarity of a solution of sodium hydroxide containing 2 grams of sodium hydroxide in 200 ml of solution. What is the formula? Molarity M is given by number of moles, isn't it? For number of moles, we are given only mass, so we will take it as W by molar mass into volume in liters. This is the formula, isn't it? So, let us substitute now. W is 2 grams, and molar mass of sodium hydroxide you can calculate and find it out to be 40 into volume in liters. What is the volume given? 200 ml. This 200 ml must be expressed in liter. You can write it as 0.2 or you can write it as 200 by 1000. The 1000 will go up. You can do in either way. You can write it as 0.2 or this way. So, this you get 5 by, this is 8. So, you get it as 0.25. The molarity is 0.25. Is that clear to you? We will do one more sum now. How many grams of acetic acid, a formula CH3COOH, are needed to prepare 50 ml of 0.05 molar solution? Here you are given molarity. You are asked to calculate the mass. You know the formula. Molarity M is equal to W by molar mass into volume in liters. Isn't it? Let us substitute it now. For molarity, we will write 0.05 is equal to W. That is what is to be calculated. And molar mass of acetic acid, you can find it out to be 60 into volume in liters. What is the volume given? 50 ml. So, as before, we will write it as 50 by 1000 to make the calculation easier. So, here you get it 20. So, it is 1 by 3, isn't it? So, W is equal to 0.05 into, already this 0 is gone. So, it is 1 by 3. So, 0.05 into 3, that is equal to 0.15. That is the mass of acetic acid that you need to prepare 50 ml of 0.05 molar solution. With these two simple problems, I suppose you have understood the calculation involving molarity. I will give you a little more practice now. You are given 6 grams of nitric acid are present in 1000 grams of solution. The mass percentage is dash. You have to find out and fill in it. 200 grams of 4% solution of ammonium hydroxide contains dash grams of ammonium hydroxide. Third problem, find out the number of moles of solute in the following. First solution, 250 ml of a 0.2 molar solution of potassium hydroxide, and second solution is 2 liters of 0.22 molar solution of magnesium chloride. These problems involve very simple calculations, so you can work them out. I will give you answers at the end of the session. We will take up molality now. Molality of a solution can be defined as the number of moles of solute dissolved in 1 kilogram of solvent. Dissolved in 1 kilogram of solvent. Molality is. Okay, see the difference. Compare it with molarity. Molarity involves number of moles of solute, isn't it? Number of moles of solute. And molality also involves number of moles of solute. Now, how do we define molarity? It is the number of moles of solute in 1 liter of solution. So, there we consider volume of solution. Molality definition is number of moles of solute dissolved in 1 kilogram of solvent. So, here it is mass of solvent. So, regarding the solute, both are same, but regarding the solvent, molarity considers the volume of solution, not solvent, and here it is mass of solvent. So, you have to be very clear about it. Now, I will give you some experimental details about preparing a 0.1 molar and 0.1 molal solution of, say, sodium carbonate. That will help you to understand the difference better. In the laboratory, we have some glassware for measuring exact volumes of liquids and solutions. Some of them are burette, pipette, with which you may be familiar, and also standard flask or volumetric flask. What you see on the screen are what are known as volumetric flasks or standard flasks. If you fill the flask up to the mark that is seen on the neck of the flask, it will tell you that the volume of the solution or liquid in the flask is exactly 1000 ml, that is 1000.0 ml or 1 liter. So, this is said to be 1 liter standard flask. Of course, you have to excuse me for the diagram. Now, using the standard flask, we are going to prepare 0.1 molar and 0.1 molal solutions of sodium carbonate. Sodium carbonate molar mass is 106. So, for 0.1 mole, we have to weigh 10.6 grams. So, I weigh exactly 10.6 grams of sodium carbonate and then put a funnel on this. And then add the salt, sodium carbonate to that, and then add distilled water little by little so that the salt is washed down into the flask. Add slowly till all the salt is washed down and then shake the flask gently and add water slowly. When you come up till here, you can remove the funnel, and after that you have to add water only in drops, either using a pipette or a glass tube. You have to add the water in drops so that the lower meniscus of the solution or liquid coincides with the mark here. Then only the volume will be exactly 1000 ml. So, now you have prepared 1 liter of sodium carbonate solution containing 0.1 mole of the solute, that is sodium carbonate, in 1 liter of solution. Now, in this flask again keep a funnel and then you can add 10.6 grams of sodium carbonate. But for water, you have to take exactly 1 kilogram. So, weigh 1 kilogram of water separately. That is, you weigh a container of W grams and then add water so that the total mass is 1000 plus W grams. So, that the mass of water alone is 1 kilogram or 1000 grams. And now, after adding sodium carbonate, pour that 1 kilogram of water little by little and then wash down all the salt into the flask, and then after the level comes here, remove the funnel and add the remaining water carefully. You don't have to bother about the level coinciding with the mark here. You have to add the entire 1 kilogram of water. Now, do you think it will be below the mark or above the mark? Whatever little it is, sodium carbonate also occupies some volume, isn't it? And then even if I assume that 1 kilogram has a volume of exactly 1000 ml at the room temperature, since the solute also occupies some volume here, the water level may be little above the mark. In the case of 0.1 molar solution, I think you can understand that water level may be little above the mark. So this is how we prepare 0.1 molar and 0.1 molar solution. Though the difference appears to be less only, but it is for our calculation purpose, we have to be very precise with regard to what we are doing. Then, after preparing the solution, you can put the lids in the flask and shake it gently to make the solution uniform. Now let us derive a formula for molality, just as we did for molarity. Molality, which is denoted by small m, we can write number of moles of solute N by mass of the solvent in kilogram, W in kg. For N, you can write W by molar mass. Molar mass into W in kg. Always W in lower case refers to the solute and W in upper case refers to solvent. So this is the formula for molality. Shall we work out one or two problems to understand the concept of molality better? Read the problem. Calculate the molality of a solution containing 4 grams of magnesium sulfate in 60 grams of water. What should you do first? Calculate molar mass of MgSO4. Mg has a mass of 24, sulfur 32, and for 4 oxygens it is 64. So you get a molar mass of 120. Now let us substitute in the formula. Molality M is equal to W, which is 4 grams by 120, and for mass of solvent it is 60 grams. So I will write it as 60 by 1000, taking the 1000 above. So you can do the cancellations easily and you can find the answer. So the answer you get here is 0.55. You can work it out. It is 0.55. Another problem is calculate the mass of ammonium sulfate. Ammonium sulfate. I am not giving you the formula, so you have to write the formula correctly and then compute the mass. To be dissolved in 250 grams of water, so that the molality is 10 to the power minus 2. So first thing, you have to write the formula of ammonium sulfate correctly using the valencies. So ammonium sulfate is NH4 twice SO4. If you get that right, that is the first thing to be done correctly. And then the molar mass is 132. Now what is given here? Molality is given 10 to the power minus 2. That is 0.01. That is equal to W. That is what you have to find out. Mass of ammonium sulfate. Molar mass you know is 132 into, and what is the mass of solvent? 250. So that is 250 by 1000 or 0.25. You can substitute it as you like. And then when you simplify, keeping the W here, take the rest over there. You can do the calculation yourself and check if you get an answer 0.33 gram. With these two problems, I think the concept of molality should be clear to you. Here are two problems for calculation of molality for your practice. Fourth one is molality of a solution of KOH containing 4 grams of KOH in 4 kilograms of water is blank. You have to calculate and fill in the blank. What is the mass of sodium sulfate that you need to dissolve in 50 grams of water to have a molality of 0.04? Write the correct formula of sodium sulfate, calculate the molecular mass and proceed to do the problem. So far the problems that we have discussed are very simple ones in which we just needed to substitute the data in the formula and calculate. Now I'll take up a slightly different kind of problem. Find out the molality of a 18% solution of glucose in water. You are given the concentration in mass percentage and you are required to calculate the molality of the solution. What do you need for calculation of molality? You need number of moles of solute. You have the mass of solute and the molecular mass is 180. Using that you can calculate the number of moles, and you also need the mass of the solvent in kilogram. You know the mass of solvent here is 100 minus 80. So you can substitute in the formula and calculate. So this is a very simple one for you to do. Let me give you another kind of problem now. Find out the molality and molarity of a 25% solution of sugar in water. Density of the solution is 1.15 gram per ml. The first part of the problem is very similar to the one I discussed just now. For the second part, where you have to calculate the molarity of the solution, you know we need the volume of the solution, volume of 100 grams of solution. So for getting volume of 100 grams of solution, the additional data you need is density, and that is given there. So you can get the volume of the solution and substitute in the suitable formula and calculate. Anyway, I will work out this problem for you. You can go through the solution given here, and I will give you a similar problem for your practice. The seventh problem is calculate the molarity of sulfuric acid solution whose specific gravity is 1.125 gram per centimeter cube, and it is 20% of sulfuric acid by mass. Specific gravity is nothing but density, and again I have used the unit gram per centimeter cube for density. It is the same as gram per ml. So you can work out on similar lines and get the answer. Now I am passing on to a slightly higher difficulty level problem. Calculate the molality of 1 molar aqueous solution of sodium hydroxide. Density of the solution is 1.08 gram per ml. We have the data that the solution is 1 molar. 1 molar solution of sodium hydroxide. That means 1 mole of sodium hydroxide or 40 grams of sodium hydroxide are present in 1 liter of solution. You have the volume of the solution as 1 liter. Let us take the volume of solution is 1 liter or 1000 ml. For calculation of molality, you need mass of solvent, isn't it? So if we can get the mass of this 1 liter of solution, let us see how we can calculate the mass of solvent. You are given density. You have volume and density of the solution is 1.08 gram per ml. So it is not difficult to get the mass of the solution. Mass of 1 liter of solution NaOH solution is 1000 into 1.08, which gives you 1080 grams, isn't it? And you know the mass of solute is 1 mole, that is mass of 40 grams. 1 mole of solute here is 40 grams of sodium hydroxide. So what is the mass of solvent? Solvent water is 1080 minus 40, so that is 1040 grams. Now it gets reduced to a very simple calculation. So molality M is equal to 1 mole. Number of moles remains the same. It is 1 mole divided by 1040 grams. Converted to kilogram, it is 1.040. 1 by 1.040. So that gives you a value of. So we find that molality of 1 molar solution of sodium hydroxide is 0.96. In this context, I would like you to answer two questions. The questions will be, out of 1 molar and 1 molar solutions, which is more dilute and which is affected by change in temperature? These are two things that you can answer from your understanding of molarity and molality that we have discussed so far. Now, after this, I will explain to you how molarity changes on dilution as the last part of the session. Molarity change on dilution. Supposing I am taking 100 ml of 0.2 molar solution. 100 ml of 0.2 molar solution and add another 250 ml of water to it. It will be any solution of any salt. It will be the same. Anyway, for your better understanding, I take it as a solution of sodium carbonate. I am taking 100 ml of 0.2 molar solution of sodium carbonate and add 250 ml of water to it. Do you think the molarity will change or not? The solute remains the same. You have not done anything to the solute. The amount of solute in the solution remains the same. You have added water. You know, for molarity calculation, the volume of the solution is substituted in the formula. So that is important. So how does it change? That is what we have to find out. New volume will be 100 plus 250, isn't it? That will be the new volume. New volume is 100 plus 250 ml. That is 350 ml. So there is a very simple formula for that. We will write it as V1 M1, that is before dilution of the solution, is equal to V2 M2. Volume and molarity before dilution and volume and molarity of the solution after dilution. You can use it only for dilution because the same solution, the same solution, I mean the solution of the same solute only is used here, only for dilution. You can substitute 100 ml here and molarity is 0.2 and new volume is 350 ml and you can find out the new molarity. See, here we are not changing into liter, we are substituting it in milliliter itself. You can substitute in the same unit of volume on either side. So it can be anything. It can be milliliter or liter, whatever it is. So when we are having the same unit on both sides, it is immaterial. And you can calculate the molarity, which will be M2 is equal to 0.057. You can substitute and find out. So this is the new molarity. And this is a very simple one. So you can do problems on dilution with this just one example. Now I will give you answers for the questions, problems I gave you in the course of this session. You can verify your answers with that. Here are the answers for the problems I gave. I want you to note the unit for molality and molarity. So the unit for molality is mole per kilogram and unit for molarity is mole per liter. Please make a note of that. And for the 8th question, for A part, a molar solution is more dilute. Even in the example that we took, 1 molar solution of sodium hydroxide has a molality of 0.96. That is less, isn't it? And also when I described to you how to prepare 1 molar solution and 1 molar solution, in the case of molar solution, you might have noticed that we take 1 mole of the solute and then add full 1 kilogram of solvent or 1 liter of solvent. So that contains more of solvent. Hence, a molar solution is slightly more dilute than a molar solution of the same value. That is, it is not only 1 molar and 1 molar, it can be 0.1 molar and 0.1 molar or 0.5 molar and 0.5 molar. When the molality and molarity have the same value, the molar solution will be slightly more dilute. Now, for the temperature dependence of molarity and molality, molality involves only masses, isn't it? Only mass of solute and mass of solvent. Mass is not temperature dependent, while molarity involves the volume of the solution. You know, volume depends on temperature. There is an expansion in volume with increase in temperature. You are aware of that. So, molarity is the one which is affected by temperature. Though it is very slight, but still out of the two, the one that is affected by change in temperature is molarity. That's about the session. I am sure you found it useful. Thank you.